There's a metaphor that dominates how we think about AI: the brain is hardware, the mind is software. It's clean, intuitive, and it frames consciousness as something that could in principle run on any sufficiently powerful machine. If mind is just code, then building one becomes an engineering problem. That framing is useful up to a point. But it contains a hidden trap, one that matters more as AI systems become more capable. It conflates two things that need to stay distinct: a model of a process and the process itself. Here's a concrete example. A weather simulation can be extraordinarily accurate: pressure fronts, humidity gradients, convective cells, and still never produce rain. The simulation and the atmosphere are different kinds of thing, regardless of how detailed the model gets. More resolution doesn't close that gap. It just gives you a better map. The same logic applies to mind. A system can model cognition, pattern recognition, language production, inference, without thereby becoming a cognitive subject. Representation and instantiation are not the same operation. There's a deeper issue with computation itself that's worth unpacking. When we say a machine is processing information, we're already applying an interpretive layer. At the physical level, what's actually happening is state transitions, voltages, charge differentials, switching logic. The abstraction of symbols, operations, and results is something conscious observers bring to that physical process. A planet doesn't solve differential equations to maintain its orbit. We solve them to describe the orbit. Computation is something minds do to the world, not something the world does on its own. This has a direct consequence. If computation already presupposes interpretation by a conscious agent, it can't straightforwardly be the explanation for consciousness. You can't bootstrap the interpreter from the thing that requires an interpreter to exist. Then there's what you might call the syntax ceiling. All Turing-complete systems are formally equivalent. They differ in speed and scale, not in kind. And all of them operate at the level of syntax, symbol manipulation according to rules. What they don't do, by themselves, is cross into semantics. A system can process tokens that refer to concepts without those concepts meaning anything to the system. Gödel and Turing both pointed toward inherent limits in formal systems, not just practical limits, but principled ones. Adding more compute doesn't change the category. It changes the throughput. Biological systems are different in a way that's philosophically significant. Living organisms aren't just executing instructions, they're engaged in what biologists call autopoiesis, continuous self-production and self-maintenance. A cell's information processing is inseparable from its metabolism, its repair mechanisms, its drive to persist. The hardware and the software, to use that metaphor, are not separable layers. They co-constitute each other. And crucially, there's something at stake: the organism's continued existence. That existential embedding may be a precondition for consciousness, not just an implementation detail. It's also worth separating two concepts that AI discourse tends to run together: intelligence and consciousness. Intelligence is about doing, optimizing, inferring, solving. These are tractable to formalization, which is exactly why machines handle them well. Consciousness is about being, the first-person fact that there's something it's like to be a system. You can satisfy every behavioral criterion for intelligence while leaving the question entirely open. Large language models make this confusion acute because they're genuinely impressive at producing human-like outputs. But the name is instructive: model. An LLM is a statistical model of linguistic production. Its fluency demonstrates that the formal structure of human language is richer than most people assumed. It doesn't demonstrate that the system has crossed from modeling language to having something to say. The takeaway isn't that AI is unimpressive, it's that we need to be precise about what it is. Computation is one of the most powerful tools that minds have developed for externalizing and manipulating structure. That doesn't make it the origin of mind. Our current AI systems are maps of remarkable resolution and expressive power. The question worth sitting with is whether we're so impressed by the maps that we've started forgetting there's a territory they're pointing at, one that no amount of added detail will ever make them become.